Hello, and welcome to Aggressive Physics. Today is day 28, and what I'd like to do today is solve some problems dealing with projectile motions at an angle. And what I decided to do is choose 4 different types of problems that you may find. These types of problems are traditionally the ones that will be asked dealing with different ways to solve projectile motions at an angle. We'll deal with problems where they land at the same height, problems where they land higher than they were launched, problems where they land lower than they launched, and then even look at a problem where possibly we throw an object downward through the air. A lot of times we deal with objects moving upward first in a specific problem. Now, however, we may deal with projectiles where we want the projectile to move downward initially in order to land at a specific spot on a court. For example, if you're playing tennis, what you're going to do when you serve is throw the ball up in the air vertically and then strike the ball in a downward direction so that you get it over the net into the service box. And in that case, you'll have an initial velocity that's downward. So that means that the VIY is going to have a negative value to begin with. Now, mathematically, that will work out the same as any other problem, but it's something that we haven't talked about before, and I want you to be aware of the different types of problems. Now remember, we're going to do 4 problems together, and these are not every different scenario that you can possibly be asked to solve. These are 4 typical problems, 4 problems that can and have come up before in past assessments, and I want you to be aware of the 4 major types of problems. On the Regents exam, on an assessment, on a homework assignment, you could be asked to solve any different problem. And what's important for you to remember is that we have dealt with different problems in the past. You are working on your problem-solving skills. And the only way to get better at this is by practice. We'll do 4 problems together, but it's important that you do your homework assignments, your classwork assignments, and other quiz and tests that you may have in order to get better at this. The more problems you do, the more repetitive you are, the easier the problems will be in the future. So as far as today goes, I think we're going to have a work day where we're going to solve 4 problems together. Now let's get on to it. All right, we're going to look at 4 different types of problems you can deal with projectiles. And this first one is a standard problem with an angle. We have a football player kicking a ball at 12 meters per second at 33 degrees. You want to find the range of the ball, which is the distance it moves downfield. Now, of course, like any angle projectile problem, you're going to take that angle and you're going to get a little angry and you're going to break some legs. So V cosine theta will get us our x, V sine theta will get us our y. So 12 times the cosine of 33 gets me 10.064 meters per second. And 12 times the sine of 33 gets me 6.54 meters per second. All right, those become our x and y givens for the velocity. Vx is 10.064, Vy 6.54, Ax still 0, Ay still negative 9.8, dx is what we're looking for, and dy is 0, lands at the same height. So in the y direction, where I know more information, I'll find time, and I'll substitute that into the x direction. So for the y, d equals vit plus 1/2 at squared. 0 equals 6.54 times t plus 1/2 negative 9.8 t squared. Factor of t. 6.54 minus 4.9t. Those all equal 0. So my 2 roots, t equals 0, and t equals, we'll bring the 6.54 over, and divide it by 4.9. We'll get 1.33 seconds. And the 1.33 is the one we're going to use. So 1.33 seconds here. dx vixt 1/2 axt squared. The a term cancels. And we're left with dx equals 10.064 meters per second times 1.33 seconds. 10.064 times second answer, and we have 13.43 meters. So the ball lands 13.43 meters downfield. Same height that it landed on, so the key to this problem is that dy is 0, and then we're able to factor out the t and solve for two t terms. All right, now we happen to be on the rugby pitch, and we're striking a ball over the goalpost. Now, the ball has a speed of 17 meters per second, and we're kicking it at 50 degrees. We want to find out how far away the person can be from the goal if it's going to barely skim the crossbar 3 meters high. So we're kicking it from the ground 3 meters into the air. Now, that being said, as soon as there's an angle involved, what I'm going to want to do is our standard procedure for dealing with angles. We have 17 and we have 50 degrees. So V cosine theta for the x, V sine theta for the y. And let's see what we get when we multiply 17 times the cosine of 50. We end up with 10.93 meters per second. And if we do 17 times the sine of 50, we should get 13.02 meters per second. All right, so then what we do in this case, as we've done before, we set up our givens list. We have our x and we have our y. And what we'll do is we'll start with v in the x, which is 10.93, v in the y, which is 13.02, a is 0, a is negative 9.8 for the x and y. At this point, we want to find dx. We don't know what it is, so I'm going to put question mark. And then dy is positive 3 meters because it moves upward 3 meters from where it started. All right, so we're going to solve for t and plug it back in and figure out our displacement in the x direction. Now, this looks like it's going to involve a quadratic. D equals VIT plus 1/2 AT squared. 3 meters equals, and this is the y direction first, 13.02 meters per second times t plus 1/2 minus 9.8 meters per second squared t squared. And what we're going to do is simplify this. So it's going to be minus 4.9 t squared plus 13.02 t. And then we'll bring the 3 over. Minus 3 equals 0. Now at this point, we're going to need to use a quadratic solver. And we're going to get 2 roots for the time. All right, using the quadratic solver, I'm going to get t to be 0.255 seconds and t to be 2.402 seconds. Now the question asks, how far can the player stand from the 3-meter high goalpost if the ball barely skims the crossbar? Now I'm assuming this means the farthest distance total. So I'm going to use the bigger time in this case. Now if we remember, there's 2 times where the rugby ball in this case will reach the goalpost. So if this is the goalpost over here, we'll hit the goalpost at these two locations, and that's what these times represent. 0.255 seconds after it was kicked and 2.4 seconds after it was kicked. And to get the farthest distance, we'll use the farther one, the bigger one, because it'll be on its way down. So that means when I plug my t in, I'm going to do 2.402 seconds. Now, before we did the soccer problem, where we calculated both, and those were the two spots they could have been located, and it wasn't as clear. This one is the farthest, is what the question asks. So now I'm going to use the x direction. And what I'll do is I'll say d equals VIT plus 1/2 AT squared. D is what I'm looking for, 10.93 times 2.402. I'll take 10.93 and I'll multiply it by 2.402, and I'll get 26.254 meters. So the person can strike the rugby ball 26.254 meters away and barely skim the crossbar 3 meters high. All right, in this problem, what we're going to look at is a baseball player who obviously has something wrong with his arm because it's got some kind of Gumby disease here. Maybe he's got two arms, kind of like an octopus or something. However, with that said, he's throwing the ball downward. So he's pitching. I don't have the ability to draw a baseball player pitching. Most of my people do look identical in nature. Now, that being said, 22 meters per second is the way I'm throwing the ball. In this case, it's with a 10-degree angle down. So instead of drawing my right triangle upward, I have the hypotenuse pointing to the downward direction. That doesn't affect the sine and cosine because the 10 degrees is still touching the adjacent here, which is the x-axis, which means I'm going to use cosine for the x, and I'm going to use sine for the y because it's opposite the 10 degrees. However, that's going to make this y component a negative value, and that will change how the roots are formed when we do our quadratic in a little bit. Now, since we've done this process many times, 22 times the cosine of 10 will get me a root of, so the x root will be 21.666 meters per second. And the y root is going to be 22 times the sine of 10, or 3.82 meters per second. And it's very easy to forget about this little negative sign. We've often worried about the signs for the displacements. That's been a standard. We've worried about the sign for the acceleration because acceleration of gravity is always downward. But we often have objects being thrown upward. So in this case, throwing it downward, the main change is that when we do our Vx and Vy, the V and the x is still 21.666, and the Vy becomes negative 3.82. And if we forget that, it's going to change the answer. In fact, when I typed it into my quadratic solver, I forgot to use the negative as well. And what ended up happening is if you forget the negative and then you add the negative for that b term, you'll actually switch which root is negative. So when we get to that, I'll explain a little more in a little more detail. Now, I just glossed over the accelerations. Of course, the x acceleration is 0. The y acceleration is still negative 9.8. And d in the x direction is what we're looking for. dy is negative 1.8 meters because the ball falls downward. Well, like every other projectile motion problem, we're going to solve for t in the direction we know the most about, and then we're going to use that in the other direction. And we know the most about the y direction. So let's solve for y. d equals VIT plus 1/2 AT squared. And negative 1.8 meters equals negative 3.82 meters per second t plus 1/2 negative 9.8 meters per second squared, t squared. And I'll simplify that by doing negative 4.9 t squared minus 3.82 t. And I think I forgot to write the t in the equation. And then if I bring the 1.8 over, it becomes positive 1.8 equals 0. So my a term is negative 4.9, my b term is negative 3.82, and my c term is positive 1.8. And I'm going to get two roots. And the first root will be negative 1.11, and these are seconds, positive 0.331 seconds. Now, of course, I want to use the positive 0.331. So when I go to the x direction, d equals vit plus 1/2 at squared. The a term cancels, and we're left with d equals 21.666 meters per second times 0.331 seconds. So I go back to 21.666 times 0.331. And when I multiply that, I'm getting 7.2 meters. I got 7.171, but I'll just round that to 7.2 meters. And depending upon if this were part 1, there would be multiple choices, and the precision would be defined by the answers of the problem. Now, in this case, octopus baseball player throws the ball downward. This negative sign here is the key. When I did this incorrectly on the quadratic solver, which I did beforehand, it actually switched the terms. The positive term was the 1.11, the negative term was the 0.331,